My name is Crystal Hopper Myers. I run our STEAM Pathways program. So basically what that means is that I get to work every day with an amazing team of professors who do really awesome things. We've got, and actually tonight we have physics, biology, chemistry, geology professors all in the house. So if you have a variety of questions, that's okay. We even have Dr. Reese here that was actually led our last lecture, engineering lecture. If you had the great opportunity to watch that, that was just amazing. I was like kind of blown away of how much I love that. So, and if you didn't, we have that on the YouTube channel with SWOCC, so you can watch it still. So today, we also have a special guest that I wanted to introduce and give him a couple minutes to talk because he traveled all the way over from Springfield to come visit us today. And we have Aaron with the Oregon NASA Space Grant Consortium. And Space Grant has been a huge help with a lot of student research opportunities that we've had here at SWOCC. They have scholarships, they help with internships, and we're just so grateful for Space Grant. Dr. Coyner and I are local Space Grant reps, so if you ever have any questions or want to get connected, if you're one of the students in the crowd, which I see, please reach out. I also lead our SPEAR team. And I know some of you students are interested in that. We have just a great group of student researchers that are always working on a lot of awesome things. Next week, we actually get to travel to Corvallis for their student symposium. So pretty excited about that. Okay, so I'm gonna take a breath because things are moving around here. Okay, so with that said, Aaron, welcome.
Thanks, Crystal. I'll keep it brief because you guys are here for astrophotography and not me. But NASA Space Grant is a program that the real goal of it is to encourage the next generation of STEM students and get them involved with science, technology, engineering, mathematics, and eventually have them go on to NASA internships. So if you're thinking about pursuing those careers, getting involved with the SPEAR program, if you're a student, right? And doing that research and then going to the symposium will allow you to kind of get your foot in the door and progress onto other scholarships like the STAR Research Scholarship. And what I'm doing is the Student Ambassador Program to come hand out pencils. But they're all great things. It's awesome, right? I've got to shake a lot of hands, meeting a lot of people. It's been fun. But the end goal is to have people go on to NASA internships. And so by meeting those people and starting to participate in programs, you kind of ratchet your way up, and it's a pipeline for that. So if you guys are interested in that, you want to come out, get involved with SPEAR, or the STAR Research Grant is going to be out November 2nd, I believe. You can Google that. I believe it's a $3,000 scholarship. Yeah, thanks.
Thank you, Aaron. He does a lot more than just hand out pencil. So, I forgot to mention that he's one of our student ambassadors. That's like a brand new program with Space Grant. We're really excited. We actually don't have one for this local area. So we're hoping to find, I'm looking at you students, people that might want to get involved to try to help share about all the cool things with Space Grant. With that said, I'm going to introduce to you Dr. Aaron Coyner, who's over our physics and engineering department here. He also teaches the astronomy classes. He is a solar physicist and could probably help answer some questions to you tonight. And one other thing I forgot to mention is Dr. Coyner and I both are NASA Solar System ambassadors for our area. And so basically what that is trying to help share information about current missions going on with NASA and putting together a lot of like community programs like this. So Dr. Coyner.
All right. Always a tough act to follow, but we will do the best we can with it. We're happy today to have we're happy today to have Al Hurt come to talk to us about astrophotography. It's always been a passion of mine, but something I fail miserably at. I love looking at astrophotographs from all different sources, but I don't have the patience, the camera skills, or the steady hand to be able to do half the stuff. So I'm always impressed whenever anybody can provide sort of inside tips and tricks for people that may be able to take the next picture that may end up in Astronomy magazine or may end up on my favorite site in the world is we astronomers call it APOD. You guys might know it as Astronomy Picture of the Day. But if you can ever get a picture on Astronomy Picture of the Day, it's always a great thing to show up. I always like going to that. We always see the NASA photos from the various satellites, some of which I used to work with. But seeing amateur astronomers and even those that are just casual astronomers being able to take pictures of the celestial bodies is as clear and as amazing as some of these are. It's always good to know some of the trips. I can't talk today. Tricks of the trade. Sorry, it's been a long day. But without that, before I stumble on any more words, I will turn it over to our actual speaker for the day, Mr. Al Hurt.
There is, oh, wow, that is loud. Okay, let's see, they gave me a pen that makes the video work. Okay, astrophotography. It's all about being in the dark. And, most of us feel like we're in the dark all the time. But so we're going to try and explore it. This is me. I don't know if I have to read it all off to you or not, but basically I've been shooting stars at night since about the 1990s. We lived in Alaska. The Northern Lights caught my eye, and I started trying to shoot Northern Lights with film cameras. And boy, when digital came in, it just changed the world. Okay, let's see if I get this going right. Oh, the old man photography. I have a van. I can park the van, go ahead and turn the seat around, the passenger seat around, make an easy boy out of it. Nice and easy. Got my heater right next to me, the coffee on the stove, and I've even got it set up so I can have my laptop inside on a table so I don't even have to get out. And I call it old man photography. Okay, here's what we're going to try and cover. There's a lot of information here tonight. I hope people have a pencil and paper. We'll have questions at the end. I'll try and get through it as quick as possible, but it is a big topic. We're going to go into the types of night photography, how to take pictures after dark, and then my favorite, the rabbit hole versus the reality. Oh, come on. There it goes. Okay, these are the main topics of after dark photography. Astro landscapes, Milky Way shots, star trails, comets, meteor showers, time lapses, deep space objects, and the moon. And I think we can all find the moon to take a picture. That seems to be one that most people get. Okay, few examples. This is Sunset Bay after dark. Call it Astro landscape. That's where you've got the night sky and you've got enough of the foreground to be able to tell where you are. the Milky Way. This is what you see when you get out. Everybody expects the Milky Way is going to be this big bright thing in the sky. It's kind of a, right there. That's the Milky Way. Now, once you understand that's what you're shooting at, you point your camera at it, when you process it, now you see the Milky Way. But when you go out there, understand it's nothing but a gray cloud in the sky. Star trails. We've all heard that the Earth rotates. Well, when you look at the stars with the Earth rotating, in this case, I'm looking north and, wrong button. And that's the North Star right there. So if you're looking north, they all rotate around Polaris. If you're looking other directions, they appear to take on different shapes. So if you look at a picture, you can tell what direction the picture was taken of by the way the stars are in the sky, the way they're moving through the sky. This was taken up at Mount St. Helens one very late night, and I slipped on the ice and busted my head. So this is a favorite of mine. There's meteor showers. This is the Geminids. That's in December. So we've got that to look forward to. This happens to be up at Mount Rainier. This is at Lighthouse Lookout. This was taken in August. It's the Perseids. You can see, if you look down here, you'll see there's our lighthouse. So here again, always including a foreground. Okay, time lapse. We've all heard that the Earth rotates and the stars stay still in the sky. But when we stand on this mud ball, we look up and the stars are moving through the sky. So I thought it would be fun to have a time lapse of the way it really is. That's the way it really works. Deep space objects. This is the Orion Nebula. Shot this out of my backyard right out here in Barview. Flame and Horsehead Nebula out of my backyard. If you know Orion, the constellation of Orion, these two are right at the bottom star, right there. That's the bottom star of his belt. The Orion Nebula is down on what we call the little sword. It's the second star from the bottom. This is Jupiter and 4 moons. Very, very highly processed. And of course, the moon. Is it me or does that look like a watermelon? You know, standing over to the side, I don't get the... This was put together as a 15 wide by 9 high presentation. And I think it's scrunching it a little bit. Or you can take the moon in multiple shots and show the actual path of the moon. This is over Empire. We were over on the other side at the boat launch. Okay, how do we take pictures at night? We got to decide what we're going to go to. We don't just wander out into a field and go, we got to find a location, because once we decide what we want to shoot, now the location makes a difference. I always say arrive before dark. I don't know how many of you have good night vision. I do not. I'm basically night blind, which seems kind of strange because I love astrophotography. But I go out during the day, I find all the holes before I step in them in the middle of the night. The setup, we'll walk through how do you actually, what do you need to do and how do you set it up? How do you align with the target? Start shooting. How many shots are you going to take and of what type? And then you process your pictures. I'm not going to go into processing. Processing, I've probably got 500 hours of YouTube video watching on how to process astrophotography. So, which of these targets do you want to shoot? You've got to actually make a decision here. When I went out and did the time lapse, that didn't just happen by happenstance. I actually had to stop and think about what I was doing and where I was and how it all worked together. Astro landscape, as you saw, we can just go out here to Sunset Bay, set the camera up, long exposure, boom, you got an astro landscape. Milky Ways, they had a star party out at Shore Acres. I took a picture of the Milky Way over the fountain out there. Star trails. Last night, I went out and took star trail pictures. I took 30 one-minute exposures because I've got a group that's asked me to do a presentation on how to shoot star trails. Comets. Here again, we've got one coming up. Shishin Shan Atlas is the next one coming. It'll be here. I'm going to be out on the 11th. That'll be our first sight of it, depending on weather. Meteor showers. There's meteor showers happening all the time, but there's the big ones where you'll get like 100 meteors an hour. So here again, you've got a plan. You've got to make a decision. What are you going to shoot? Time lapses, deep space objects. If I'm going to put all the time into setting up a telescope or setting up my camera, polar aligning the tracking mount and setting up the tracking, I better have a pretty good idea what I'm going to shoot. And of course, the moon, you can shoot the moon any night except new moon or when it's not there. Okay. For most night landscapes, you got to have an object in the foreground. You got to have some kind of scale. This was an old building we found out in the Palouse up in Washington. You can leave it with natural light, or you can do what they call light painting, which is actually taking a flashlight and flashing the flashlight around it. And of course, deep space objects don't need a foreground. You aren't ever going to get a lens that'll show you a deep space object and a foreground. Okay, now we've decided what we're going to shoot. Now how do we, where do we go to shoot it? These programs, PhotoPills, Planet Pro, and Stellarium. Stellarium out here is a planetarium type product that you can put on your laptop, or it's got them for a tablet and it's got it for the phone. So you can always have a planetarium in your pocket. For sky conditions, there's clear outside, light pollution, and the aurora. So these are 6 of the programs I use. I've pretty much gone down to using Planet Pro today. They've increased it and added so much to it that that's the one I'm preferring. This is PhotoPills. I took this from their ad about 6 months ago. So if you want to read it, go ahead. It's a great program. It was one of the originals. They have a lot of good tutorials out on YouTube on how to use it. And they've got just a ton of features on it. Planet Pro. The reason I like this is because this screen right here. Once you locate where you're going to shoot from, you can hit this virtual viewfinder, and it will show you a pretty good representation. In this case, I wanted to shoot a supermoon going up the side of Mount Rainier. Well, this showed me that this little dirt patch right here, about 10 foot square, next to a busy highway. The busy highway is here. This was a gas station and a fast food restaurant, and over here was a storage unit. So we did not have much space. We had about 10 foot. Called a buddy and we ran out there because the program said we would be able to get the shot, and this is the shot. The moon went right straight up the side. So, and they're continuing to improve this program. This is stellarium, and I've cut it down. This is the comet that's coming. And, but it is just you can add or subtract as much as you want to this program. Like I say, it's a planetarium program. Clear outside, this program tells you the condition of the sky in great detail. How much cloud cover there is up high, in the middle, and down low. The type of cloud cover. It's very comprehensive. Light pollution. Somebody asked, where do you go to get pictures? And this is the program that tells you where the lights are brightest. If you notice over here, it's all yellow with red dots. That says that's a bad place to try and get a picture at night. If you notice this white area here, that's Nevada and Idaho and that middle section there. Great places to go. And then, of course, we've all heard that the aurora is going to be great tonight. Well, I looked up on my software and it says we aren't going to see the aurora tonight. So instead of canceling, I decided to come here because there's no aurora to shoot. Okay, of course, arrive before dark. And when we're talking about getting dark, you can shoot the sunset. And then you've got what's called golden hour, which if anybody's into photography, everybody's got to go shoot the golden hour. Because of the way the light is, it makes everything just look beautiful. And then once it drops below the horizon, you have the blue hour. And then you get into the twilight hours. Nautical is 6 to 12 degrees below. Astronomical twilight is 12 to 18 degrees. And nighttime is considered 18 degrees below the horizon. And each of these has its own specialty of what type of light is there and what you can take pictures of. Am I going too fast or? Okay, setup. We're going to spend some time here. What do you need? You need a sturdy tripod. Not a spindly little thing, but something that's like a rock, because you're going to put your camera on it and you don't want that camera to move while you're taking pictures of the stars. You want pinpoint stars, and you want them just right. So the camera can't budge. I see so many people out there trying to use these little tiny tripods that wobble and sway in the breeze, and they just don't get good results. And besides, I see people out there with $10,000 worth of camera, and they put it on a $49.95 tripod. And I have a problem making that work in my brain. Camera, a DSLR, mirrorless, or a cell phone. And yes, even cell phones can take some pictures. About 3 years ago, I got my cell phone out and decided to take a picture of the Milky Way. And by golly, I was able to do it. Now, they've advanced quite a bit in this time. So I understand that there's quite a bit more. The only problem with the cell phone is that when you get a good picture, you can't blow it up and put it on your wall. They're good up to 5x7 looks good, 8x10 is iffy. So that's the only drawback to a cell phone. But if you're doing it for social media, it works great. DSLR, that's a digital single lens reflex and mirrorless. And the only difference between them is that a mirrorless does not have a physical mirror in front of the sensor. I'm staying with the DSLR because I like to take pictures at sunset of the green flash. And that means I'm going to point my camera straight into the sun for maybe as much as 5 minutes just to get a 2 or 3 second exposure of, just when that flash happens. A mirrorless, you're exposing the sun straight into that mirror, that sensor, and it's going to burn it up. Lenses. If you're doing landscapes, wide angles. When I was doing star trails last night, I was running 14 millimeters. Telephotos, if you're doing deep space objects. This is, we call this the camera bag. And as you can see, I've got a very sturdy tripod and my camera on top of it. There I'm shooting a 600 millimeter. I've got bigger lenses now. Make absolutely sure in this digital age that you have extra batteries. Mirrorless cameras, for some reason, eat up batteries like they're going out of style. And there's nothing that ruins your night imaging session like all of a sudden your camera stops working because you don't have a battery. And the last thing on the list down there, warmth, I think is the most important because we have shot all the way from sub-zero temperatures, sometimes to get what you're looking for. The colder and crisper and clearer the air is, the better for night photography. The thing that kills you is moisture in the air between you and your target. So take lots of warmth with you, no matter how warm you think you'll be with your coat. Grab an extra one. That's experience talking. My wife and I were over here on the coast one day and something was happening at Mount St. Helens and I had to run over there. So we went out to Walmart, bought a couple of those Walmart blankets, got over there, we were in the car, froze our backsides off all night long. So warmth is very, very important. Nice to have a loop, which is nothing but a fancy name for a magnifying glass. Because as you'll see shortly, when we go and look at the back of our camera to focus, you put that magnifier on there and so you can actually look at the pixels to count the pixels to make your stars very sharp. A lens heater. When you're out in the cold, the lenses tend to fog over. You don't want that foggy. So you've got this lens heater that's run off of a battery. It wraps around the barrel of your lens and runs off of a battery and keeps the lens just warm enough that it doesn't fog up. Doesn't work everywhere. I've run into cases where the lens heater couldn't keep up, but 90% of the time it's a great thing. And then a shutter release or an intervalometer, which is nothing but, an intervalometer is nothing but a fancy shutter release that allows you to program in when it takes a picture. I use just a shutter release because of the type of camera I have. I can just lock it on and just let it take picture after picture after picture. Nice to have. This is when you're starting to get fancy. You've got the mini tracker. This is the one I have. This is your middle of the road. And then, of course, when you get into the bigger stuff, you need big, heavy trackers. They now have another type of tracker out called a strain wave tracker that probably is the one I have to move up to. Dear. Okay, setting up. We're actually going to go through what you need to do to get ready. So you set up your tripod, remove the camera strap. I see a lot of people out there with the strap on their camera swaying in the breeze. In night photography, you're trying to stop any motion. No motion equals sharp stars. If your camera moves at all, your stars go fuzzy. And since I'm saying that, this next one seems kind of funny. Turn off vibration reduction. In the camera, the vibration reduction is always searching for movement in the camera. When there's no movement, it adds a little movement to see if it's still working. So you got to turn off the vibration reduction when you're using a tripod. And you turn off autofocus. Night photography is all manual. You're in control. The camera does nothing except what you tell it to do. You set your ISO. I usually start around 1600. And you can go up and down from there. Shutter speed, 15 to 30 seconds. Aperture f2.8, or if you've got a 1.4 lens, you can go to 1.4. But this gets you your initial look at the sky. You know, you take a picture and you look at it and say, wow, it's too bright, it's too dark, it's whatever. And then you adjust your camera from there. Set your color balance at 4,000 Kelvin. I've used auto exposure on it. You know, the one that tells you, well, I'll set your color for you so the color's always right. It's not always right, especially at night. Figure out how to set your camera to 4,000 Kelvin and you'll be very close to the ballpark. Then we're going to turn on live view, which says, I'm not going to be looking through my camera. I'm going to be looking at that screen on the back. You set the screen brightness to minimum because out there in the pitch dark, that screen just will blind you. And especially for a guy like me who's night blind, it's like, wait a minute, where'd everything go? So set your brightness to minimum, and then I put it on the tripod. Usually I just do all these steps right here in my lap. So it's easy to do rather than getting it on the tripod like several people do. And now you're punching and you got these lights flashing every time the screen comes on. It's just an easier way to go. You take an exposure and look at your screen and see if it looks any good or not. If it looks good, then what you do is you've got live view on, you find a star in the sky that's bright enough that you can see it in your screen in the back of the camera. And then you can focus on that. That's where that loop comes in that we talked about. Once you think you've got it focused, now you put the magnifier on there and play with it until it's really focused. Always shoot in RAW. It gives you the best ability to change anything, colors especially. And in night photography, colors are phenomenally pretty. how do I want to say it? If you don't shoot in RAW, you can't adjust the colors to be able to see the color of the stars. And the stars are all different colors. They're not just white. When you're shooting, check your focus every hour or so, because when you're out in the cold, you know, a little breeze comes up or something, all the components will get cold and change. They'll shrink up, and it changes your focus. So, you know, when you're getting into astrophotography, you're playing a game of degrees. And use only dim red or no lights at all. No lights is the best. Usually if somewhere like where we've got the van parked and the camera's that far away, you don't even need lights. You know, you can take those 2 or 3 steps and get to your camera and check things. How to focus. That's a big topic. As you'll notice, I'm a little out of focus here. You go out during the day and you can set your camera up and find a mountaintop as far out as you can. And you focus on that and then take a piece of tape and very carefully put it over your focus ring. And then you leave your camera on the tripod, sitting there waiting for it to get dark so you can take your pictures. The other one is called a hyperfocal distance. I put this chart up here. I stole it from somebody. And the biggest problem with hyperfocal is this phrase right here, acceptably sharp. You want sharp stars. You don't want acceptably sharp, you know, and who determined what acceptable is? I didn't. So the way I do it is I use live view, I find a star, and I focus on the back of the camera, and I use my little magnifying glass. That's how I get sharp stars. And then if you know, setting your shutter speed, you've got the 500 rule and the NPF rule. 500 rule says 500 divided by your focal length. In this case, a 24 millimeter makes it 21 seconds to keep your stars sharp. And I added crop sensor because not everybody's got a full-size sensor in their camera. The NPF rule is much more complicated. It takes into account the size of your sensor and just 100 other options. So use the calculator. Most of these programs that I showed you have a calculator for it. And if you'll notice that it says 5 seconds is what you need to keep the star sharp versus 21 seconds. I go with NPF every time. Okay, now we got everything set up. Now we got to align with the target, especially if you're shooting deep space. If you're trying to get the Whirlpool Nebula or the Whirlpool Galaxy, you know, it's you don't see it in the sky. You gotta find your way there. These are 3 programs that I use. They're all basically the same. What I do is I'll take, if I'm out at a site that I've never been to before, looking for the North Star, because you have to polar align your trackers. This first one here, sky, it actually has a red function on it and a search. So you tell it, I want Polaris, then you hold it up to the sky and it actually points, go this way, go that way, go the other way. I mean, to me, not being an astronomer, that's the way to go. StarWalk, Skyview, they're similar programs. You know, some of them, they're all free, all three of these. Okay, here we get into the bones. Start shooting. How many shots you gonna take? You know, what type? Single, multiple, telephoto, wide angle, panorama, or shoot to combine the sky and the foreground. These are all decisions you have to make. So we're going to go through each of these and see about how many shots. In Astro landscape, this was taken up at Hug Point. And, you know, with the clouds and the moon down below, the moon down here, and the clouds and the stars in the sky, I thought it made a pretty picture. But do I shoot a single shot? Do I bracket it? Which means taking the normal exposure and one that's a bit higher and one that's lower, so you can combine all three, because sometimes things are bright. You know, you got to work all those factions down in post-processing. So we're gathering data. You could take multiple shots and stack them to show motion. You know, you see the clouds here, how they're strung out. I've taken multiples, which give me very much the same effect. It's just a longer exposure. This is out at Shore Acres. They had a star party out there a couple of days ago. And I was really happy. Here's the fountain, the Milky Way, and the space station, the ISS going over. It was just one of those, you look up and go, that's a fast mover. Quick, hit the shutter. Milky Way. Single shot. This is a single shot of the Milky Way out at Ketching Slough. Or you can bracket them. When I was at Shore Acres, I was bracketing my shots. You can take multiple shots and stack them for noise reduction or enhancing the details. And then Milky Way arch. Everybody's got to get a Milky Way arch. This one happens to be over Mount Rainier. And that was a spooky place to shoot, Mowich Road. I thought I'd seen a wolf out there, and I thought, man, my eyes are playing tricks on me. Come to find out, they had 7 wolves get out of a game reserve, and they'd caught all but 2. So that being very cautious of all the noise in the brush. So for a panorama, you need multiple shots, and you've got to make sure that you can capture your foreground and the top of the Milky Way. I missed on the top. But each shot of the panorama could be made up of multiple shots. So if you want more detail, you may take 3 or 4 or 5 or 6 shots here in this panel, and then this panel, another 6, and that panel, another 6, and you combine them all together individually, and then you build them into your major panorama. So things can get very complex very quick, depending on what you want to do at night. Multiple long exposures. This was out at Shore Acres the other day. There's the fountain. There's the gift shop for those who have been out there. And the red lights, that's all the red lights. I mean, we had a gazillion red light hats out there. And then the green lights are the lasers that they were swishing through the sky to show people where things were. I thought it made it kind of a nice shot. Comets. This was Neowise out at Mount Rainier. You can do it in a single, or you can do it in multiple shots and stack them, depending on the detail and the noise reduction. Some of the new noise reduction programs are phenomenal. You don't need to take as many. Meteor showers, they're easy. You set your camera up, point it where you want it, turn it on, and let it just take picture after picture after picture all night long. And then comes the real work. You go through them and you pick out the shots that have the meteors in them. You know, I've come back with as many as 3,000 shots in a night. And out of that, I might have 10 or 15 meteors. So, you know, your post-processing is where the work really is. Like I say, this is old man photography. You know, you sit there and let the camera do all the work. Deep space objects, this is Andromeda. Usually you take multiple shots and stack them for noise. And then once you've stacked them all, because your target is going to be probably about that size, you got to get it as clean of noise as possible. And then you start blowing it up and you start stretching the picture, and pretty soon you come out with like that, with a little extra. The moon, 90% of the time it's a single shot. And the big thing about the moon is remembering that it's a reflection of the sun. You know, people go out there and say, well, I took a 1-second exposure of the moon and it just turned out white. What did I do wrong? Well, if you tried to take a picture of the sun, you'd turn your exposure way down. This was shot at about 1/320th of a second. So the moon is not what you think. It's very bright. So turn your speed down. And you can take multiple single shots and stack them in the software. Boy, now that I'm standing this close to that big a screen, it's not as good as I thought it was. And that brings us around to processing. I'm not going to talk about processing because, like I say, I've got hundreds of hours in study on how to process pictures, and it's very dependent on your software. The common ones are Lightroom, Photoshop, and I use this Topaz Photo AI. These all cost money. Sequitur for stacking is free, and Star Tracks. I use Star Tracks today for first time in about a month. This summer has just not been good for astrophotography. But processing, we can take hours and hours talking about it. Suffice it to say, find a program, learn how to use it to process your stuff. YouTube channels that I follow. Nightscape Images. This gentleman is, I think, New Zealand or Southern Australia. And he has some phenomenal images. He light paints them. He takes a flashlight when he's out, and he'll light up, like you can see where he lit this thing up. Peter Zinkla. He started out small, kind of like the equipment I use, and he stayed there. So he's always got a lot of good stuff out there. Astro Backyard started out like the rest of us, but he's gotten up to the point where he's now going to all the conferences. He's testing equipment for the manufacturers, and he's working with bigger telescopes. Still, every now and then, he'll pull out his old gear, go out on a trip somewhere. And but as you can see, he's got some pretty good stuff. This picture just is from Minnesota, we had a friend, we stopped at their house on our trip, and the lady was very interested in photography. I said, well, why don't we just take a picture of the Milky Way? It's right out your driveway. And she goes, what? Like most people, you don't look up in the night sky. Well, there was a cloud there, and there's their driveway. Kind of looks like the Milky Way is right there. You know, and until you show people where this stuff is, you know, you live 2/3 of your life without ever looking up. You know, during the day, it's sunny and you're looking around. At night, everybody's in their house with the big blue screen on. So it's a way to get out and see the other half of life. If you want more information, you can email me. I came across this video the other day, 80% of astrophotography basics in 20 minutes. It's a good one. It's a good follow-on to this. Now the rabbit hole. Believe it or not, these are wireless telescopes. This is one of the latest strain waves. And if you'll notice, it doesn't have this big weight going down the back. So they've figured out a way to be able to carry the weight without having that extra balancing. But, you know, you start getting into this, like I say, it's never enough. And then you got to move up again. This is a 20-inch telescope at Kitt Peak Observatory. I spent a week up there on the mountain with the astronomers taking pictures and learning how. And then you even get deeper into it. This is a picture of a wall in the Lowell Observatory, and the date is 1927. They were looking for the planet Pluto. And they actually wrote their notes right on the side. I mean, you're getting pretty deep into it when you're looking at notes written on wood. It's the rabbit hole. The reality, this is what we see most of the time. You know, I've taken you up to the top of the mountain. Now let's drop down the real side. When it's clear, it's fantastic shooting around here. There is more to take pictures of. We've been here 3 years. I've been shooting for 3 years, right out past Charleston. I keep finding new things to take pictures of. I built a pillar in my backyard because the Orion Nebula comes right across the sky in my backyard. So, you know, the Horse Nebula, the Flame Nebula, Orion Nebula, Running Man. I mean, they're all right there in my backyard. People think I'm nuts because I built this pillar back there to hold my camera. Well, she does anyway. So I've tried to go quickly. Did I go fast enough? Do we have questions?
Just raise your hand if you have a question. I'll come to you.
Oh, Steve over here. He's always got a question.
Sorry, I didn't.
Topaz. What's so good about topaz?
I like topaz. I use both Enhance in the Lightroom and topaz. Topaz gives me more latitude. It allows me to actually gauge how much noise I'm reducing. Sometimes if you reduce the noise too much, things look like they're plastic. So you got to back it down to where they look real. Enhance in Lightroom does not give you that ability. Now, go out and buy it. Oh, he's got it. See? Yep.
you talked about star parties. How do we learn about those?
The only way I learned about that one was by word of mouth. Somebody made a comment and I went digging around, talking to the rangers out there. This one came off very well and they're planning to do it again next year. But other than that, I've seen, I saw an advertisement for a star party, but it never happened. They kept getting put off and put off and put off and waiting for those clear skies.
What is your favorite photo you've ever taken?
Say that again?
What is your favorite photo you've ever taken?
My favorite photo? Whoop. The one I took last night. Sunset Bay. There's a boat going across there. A car kindly lit up with his headlights as he came around the corner. We've got a couple of Starlinks. And if you'll notice, north is up here. And you see the way they're all going around this way? Well, right here in the middle, notice they start going the other way. So it all depends on what direction you're looking, what the star trails will look like.
Oh, fantastic work. You mentioned Starlink and it triggered a question in my head because I've had a lot of conversations with a lot of my astronomer friends and they cannot stand the Starlink satellites because they'll go to do long exposure things or they'll go to do long time observing of particular targets and then their picture just gets blindsided by an entire constellation of Starlink. How do you deal with that in post-processing? And then has that ever happened to you to where they really get in the way and they mess up the shot, or are they just kind of there and you get used to them?
They do get in the way. They're not lily white in my book. But in this picture, you see where these two Starlinks are heading? Right out in this area, there seems to be an area that they cross. In doing night photography, I've seen as many as 6 out there, all crossing right down in this area. So we've got an area where they cross. But what I'll do is I'll get rid of them from the single frames. So most of my work is stacked. So I'll take multiple frames and put them together. Well, maybe one of the frames in the middle has this Starlink in it. I can go to that particular shot and take it out, and it doesn't hurt anything. If I try to put it all together and then try and take it out, then it makes all these look hinky, all these star trails here. I did this today, and I can tell you, yes, it does make it make it look hinky. And
Time you think, hey, we're doing your shots. I mean, you go out and you shoot hundreds and hundreds of shots. But when you go home, how much time does that take out of your day just to do it?
it depends. In this case, what I did was for this other class was I took these star trails and I marked them. This is 30 minutes time, 1 minute per exposure, 30 exposures, 30 minutes. That's 25 minutes. That's 20 minutes. Oops, wrong button. That's 15 minutes of exposure, 10 and 5, and then the original. And that's what you see when you go out there. So I've spent probably 2 hours putting that part together. It depends on what the shot is and what I'm trying to do with it. If it's something I'm just going to throw up on Facebook, I'm not as picky. If it's something I want to print, I'm going to go in and pixel peep, you know, and see, are these stars truly, truly sharp? You know, so that's kind of a hard question to answer. If I go out like I used to with out on Mount St. Helens or Mount Rainier and take 1,000 or 2,000 or 3,000 shots in a night, yeah, it takes me all day and then some. So, but since we've been here, I don't think I take that long. Yeah, look at her over there smiling, going, yeah, okay.
So you mentioned the green flash. I admit I always thought that was a myth. What does it look like? How do you get a picture of the green flash?
Oh, I've got many of them.
How? What's it look
Right
like?
here, standing over a little bit from where I took this picture. What happens is when the sun sets, it sets into the atmosphere right above the ground. So you're looking through a lot of atmosphere to see the sun, and it acts like a prism. Now I've got flashes with red, blue, and green. They tell me red is very hard to get. I didn't think so, because it's easy. It's easy for me because I sit there with that long telescope lens, and I can watch through that lens until I see it coming. And I can tell you that as it drops through the atmosphere, the sun starts to distort. And when it distorts, that's where you see the green flash. Okay?
Does anybody else have any questions? Just raise your hand.
You have the diagram with the sun going to the horizon. Does the timing on that vary
Yes.
year? Or is there like a, degrees per hour?
I'm trying to get back to here. Okay. It's the number of degrees, and that changes. How fast the sun is setting, where you're located, where you're looking. You can use one of these programs and they'll tell you when sunset is and when night begins. But all these times in between, you know, the blue hour down here under civil, that's usually where I stop shooting until I get to full night. You know, that's when I grab my candy bar and my coffee and soda pop and anything else that'll keep me awake the rest of the night. So yes, these are not a set time. Blue hour is not an hour. Golden hour is not an hour. It's how long does the sun take to move through the sky.
And so the civil to astronomical are not really ideal for the photography.
Well, the picture on the background here, that was taken probably nautical twilight. Once you think the sun has gone down, if you do a long exposure, you'll find out it's still lighting up the sky.
So in terms of if you're someone who wants to get started doing this kind of stuff, but like not really sure what all you need or how to get it all, what would you say is like a minimum in terms of like financial cost of like the right kinds of cameras and lenses, tripods, or like other equipment in general?
I would say if you wanted to get started as cheap as possible, buy a tripod and a head for your cell phone. Most of the cell phones nowadays, young people think nothing of spending $1,000 on a cell phone, which, you know, us old people don't do. but I will spend $2,000 on a camera. But to get started with minimum investment, I'd say a cell phone and a tripod. If you want to go with a camera, I would buy a used DSLR. And if you want to do mostly this blue hour, golden hour, blue hour type photography, get a 24 millimeter lens that'll go maybe f2.8. And you can buy those used. Probably get started for $600-700. There's several outfits online. One is called KEH. I don't know what that stands for, but they sell used equipment. There's another one called MTI, and they also sell used equipment. Just go out and search on the internet under used camera equipment. That's the way I do everything. I've learned to use the internet. Facebook Marketplace, okay?
Does anybody else have? Oh,
Your question on the lens. Have we got enough time for a quickie? Okay. This is catching slew. I was out there with Steve the other night and purposely kept swapping lenses. Okay. So this is a 14 millimeter lens. You can see how much it gathers. Now keep your eye on that little dot right there. Okay, so that's 14 millimeters. That's 24. See it right there? That's 50. That's it right there. This is 70. It's right there. This is 105. And this is 200. So as you, oops, I hit a wrong button. So what size lens do you want to shoot? Yeah.
does anybody else have any other questions? Oh,
Uh-oh, one of these knowledgeable people.
oh. Oh,
No, he's pointing to somebody else.
sorry.
Maybe I got a chance.
The direction.
When they told me all these professors were in here, I went, oh my gosh.
So if you were to shoot through a telescope, through a mirrored telescope, how does that limit you, and how would it let you do more than with, I don't know, just like your normal camera? Like if you were to point your favorite camera down the lens of a really big telescope with a mirror, like the extra light, I assume, would give you the ability to see more, but maybe there would also be some drawback. Just kind of curious.
Okay, cameras and telescopes is an interesting topic. You're talking about like a Schmidt-Cassegrain grain telescope. And what I've done is I've got a T6 adapter for my camera, which fits right in the eyepiece, and I can take pictures that way. The problem with that is it gives you such a narrow field of view. The bigger your telescope, the less you see out there. So now it's a matter of, what am I going to shoot? All right. I visited a guy who had a 50-inch telescope in his backyard. He had a house that rolled off of the top of the telescope. He didn't move the telescope. The house rolled over it when it was time to put it away at night or during the day. Here again, the rabbit hole.
Did I miss anybody else? Okay,
Yay, the torture is over.
watch your eyes because I'm going to turn the lights on so everybody can see, okay?
Oh, bodies, man. Oh,
Thank you, everybody. If you missed Al's contact information, or if you have any additional questions, feel free to grab one of my cards up there, shoot me an email, call. I'll get you connected with Al to answer, anything that comes up. If you did not get a chance to look, we have some of his awesome photography on display over here. Some of the images that were actually up there are down there, so you can kind of get a closer look to them. Also, if you would just sign in, that does help us with being able to continue bringing these types of talks here so they can show, the interest of how many people showed up and all that. Again, thank you very much.